Hello everybody, this is a lecture for College Algebra Math 13-14. Today we're going to be looking at how do you solve a polynomial equation or equation with a polynomial function where we know a particular zero, where we know where the function crosses the x-axis. Let's read the problem carefully. Solve the problem. Solve the equation 3x cubed minus 31x squared plus 82x minus 24 equals to 0, given that 4 is a zero of the following function f of x equals 3x cubed minus 31x squared plus 82x minus 24. All right. Now notice that in this particular problem, we are given one of the zeros. So what we are given is we're given one of the answers to the problem. We will utilize that particular given zero at the very beginning. This is what's going to help us to solve this problem. Let's rewrite the equation. 3x cubed minus 31x squared plus 82x minus 24 equals to 0. If we look at the left-hand side of the equation, we will notice that this is our function. So what we really have is we want to know where f of x equals to 0. That means we're looking for the zeros. The problem gives us, given in the problem, that 4 is a 0. Okay? One of the things that should trigger into your minds right as you read the portion of the problem where it says, given that 4 is a 0, you need to be thinking about, all right, I'm going to use synthetic division to divide my function by that 0. So step number 2, if you will, what that's going to have to lead you into is understanding that when you do indeed use synthetic division, and when you do divide by that 0, your remainder will be 0. Let's see. I'm going to use synthetic division, and I'm going to divide by 4. When we use synthetic division, we go back to the function and we recopy all of the coefficients and the constant of the function. Let's go down and recopy. The coefficients are 3, negative 31, 82, but then we do have a constant, negative 24. Please don't forget, keep the signs. If it's a positive, it's a positive. If it's a negative, make sure you have a negative. All right, now we're going to divide by that 4. Do not change the sign on that 4. 4 is a 0. It's one of your answers. We're going to divide by 4. Let's perform the synthetic division. In synthetic division, we always drop down that first number. Whatever it is, just drop it down. Now we're going to multiply. We will multiply 3 times 4. That will give us a 12. We will combine negative 31 and a positive 12. Another way of saying 12 minus 31. That will give us a negative 19. Now we're going to multiply again. 4 times negative 19. Positive times negative is negative. 4 times 19, negative 76. The next step is to combine. 82 minus 76 is a positive 6. Now we will multiply. 6 times 4 is 24. Now guess what? Again, we're going to combine, but when we combine negative 24 and a positive 24, look what we have. The last number we'll write is a 0. I'm going to put this number in a box. That will trigger my memory to remember, okay, the last number is my remainder. And what we know, if the remainder is 0, that number that we divide by is indeed our 0. So that 4 is a 0. Well, we knew that from the problem, so why did we do it? Well, the reason we did this step is, remember that when we divide using synthetic division, remember our quotient. So let's look at the synthetic division. Let's go quickly and maybe write down all of the portions of the synthetic division. Well, notice that at the very beginning, the coefficients and the constants that we took, this was our function. Well, not only that, these coefficients and a constant, they're not only coming from the function, but they're also, in the division's sake, they're also belongs to our dividend. What we're dividing by, that 4, this comes, or a part of, what we call a divisor. And of course, if there's anything left over, as I said before, this will be our remainder. But what we also have is all of these numbers. Okay? Let's look at all of these numbers. They will be part of what we call a quotient. And remember, a quotient is a result of the division. So let's write our quotient. When we perform the division, remember that division slices, if you will, your exponent, your highest exponent of the dividend of your original function. It decreases that highest exponent by 1. So if we started our function and our function was cubic, go back to your function. Notice that in our function, look at the leading term, 3x cubed. That power of 3, that is the highest exponent, the highest power. It tells us that the function is cubic. Well, when we divide our quotient, if we decrease by 1 that exponent, our quotient becomes quadratic. Let's see what we have. So our quotient now is really 3x squared minus 19x, and that 6 becomes our constant. But not only that, what this particular division allowed us to do, it allowed us to factor, not fully, of course, but to start factoring our original function, where one of the factors is that quotient. Notice how I wrote 3x squared minus 19x plus 6 in parentheses. But we also have another factor, x minus 4. And that 4 is actually that 0 that we started with. And notice how I wrote that factor. That factor is written in the form x minus c. So if we go back to the original problem, remember how our function was equal to 0? We had an equation. So now we will take these factors and we will set them equal to 0. So our synthetic division allowed us to begin factoring something that we couldn't factor before. But what do we do now? We only know one of the answers. We only know that 4 is a 0. We don't know anything else. But now notice, go back to your quotient. Go back to this factor. Isn't that a quadratic factor? So now what we have, we can take this factor and set that factor equal to 0. Well, remember, how do we solve quadratic equations? We have options. We can see if it factors. So factor if you can. If you cannot, you can complete the square. Okay, if you don't remember how to complete the square, remember that quadratic formula will always work. And as a kind of reminder, if you will, let's write down the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac divided by 2 times a. We'll go back to your quadratic equation. A is 3, b is negative 19, and c is 6. Let's plug it in. I'd like to use quadratic formula. X equals negative, remember the b was also negative 19, plus or minus square root b squared, negative 19 squared, minus 4 times a, that's a 3, and times a 6. We will divide everything by 2 times 3. Remember, 3 was a. Let's simplify negative and a negative. So negative 1 times negative 19. Positive 19 plus or minus square root of negative 19 squared. That's 361. And then remember, we will multiply negative 4 times 3, which is negative 12, times 6, which is a negative 72. And we're going to divide by 2 times 3, which is 6. Let's keep simplifying. 19 plus or minus square root of 361 minus 72. That's 289. And we will divide everything by 6. Now let's take a square root of 289. 19 plus or minus 17. We will divide by 6. Well, before I'll go on, notice how when I simplified, my radical went away. So I could have really factored this problem. But I wanted to show you the quadratic formula so that you know that it will always work. If you just happen to forget, how do you factor? Well, you don't want to factor. All right, now notice how we have a plus and a minus between 19 and 17. This will separate our problem into 2 answers. All right, we have 19 plus 17 divided by 6 and 19 minus 17 divided by 6. 19 plus 17 divided by 6 is 6, and 19 minus 17 divided by 6, 1/3. Okay, so what did we get? Well, let's go back. Notice at the very beginning when I started to fill in all the A's, B's, and C's into the quadratic formula, I wrote x equals. And we simplified and simplified, so now we have 2 solutions for x. X equals 6, and x equals 1/3. Okay? But don't forget, we also, remember how the problem gave us that 4 was a 0? We also have x equals 4. So what we really have is we now found our 3 zeros. We found the answer to the problem, but what's more important, we found were 3 areas on the graph where the function crosses the x-axis. Let's write them in the solution set. They are 1/3, 4, and 6. And we're done with the problem.